Here's a question neuroscience still hasn't answered. Can genius be found? Not learned, not earned, found. Somewhere in America, right now, there is a jar. Inside that jar is something so valuable that a man risked his entire career to steal it, gathering dust for longer than most marriages last, 43 years. That's how long the answer waited in that box. You're about to get it in the next 10 minutes.
What if the key to human genius was locked inside a single glowing brain?
It just disappeared. And when Einstein's own family found out what had happened, their reaction wasn't what you'd expect either. Harvey lost his medical license not long after the theft became public. He didn't return the brain. Instead, he sliced it into roughly 240 blocks, sealed them, and kept them moving city to city, job to job, for over 40 years. At one point, journalist Michael Paterniti tracked him down and found pieces of Einstein's brain sitting in a Tupperware container of cider boxes in Harvey's Kansas apartment. Here's the detail most retellings skip entirely. Einstein's son, Hans Albert, eventually learned what Harvey had done and confronted him directly. According to multiple accounts, Harvey convinced him the research was too scientifically important to abandon, and Hans Albert, reluctantly, agreed to let Harvey continue holding on to it, on the condition it only ever be used for legitimate research, never for public display. That reluctant, informal permission is the only reason Harvey's decades of quiet possession was ever treated as anything other than outright theft. And then, decades later, something actually happened with it. In 1985, a neuroanatomist named Marion Diamond at UC Berkeley finally got samples to study. What she found didn't shock the world, but it shocked her, quietly, in a way that took years to publish. Einstein's brain had a significantly higher ratio of glial cells to neurons in one specific region, the association cortex, than the control brains she compared it against. Glial cells don't fire signals like neurons do. For most of the 20th century, scientists mostly ignored them, thought of them as scaffolding. Diamond's data suggested something else, that they might be doing metabolic support work tied directly to higher-order thinking. It was a single study, on a sample size of one brain. She said so herself. The finding was real. The certainty wasn't. And here's where it gets stranger. In 1999, a second researcher, Sandra Whittleson, at McMaster University, got her hands on photographs Harvey had taken of the brain before slicing it. She found something structural this time, not cellular. Einstein's parietal lobes, the region tied to spatial and mathematical reasoning, were about 15% wider than average. And a groove called the Sylvian fissure, one that normally runs through that region, was almost entirely absent. Whittleson's theory that missing groove might have let neurons in that region connect more freely, instead of being physically divided by it. And there's a third study almost nobody outside neuroscience circles has heard of. In 2012, anthropologist Dean Falk led a detailed analysis of Harvey's surviving photographs, and found something else entirely. Unusually complex, extra folding patterns across the prefrontal cortex, the region tied to planning and abstract thought patterns Falk described as more consistent with what's typically seen in far younger brains. 3 separate researchers, 3 separate decades, 3 separate physical anomalies, and still none of them able to prove which came first, the anomaly or a lifetime spent using it? Here's the uncomfortable part none of the three studies can answer. Was Einstein's brain built different? Or did a lifetime of a very specific kind of thinking build it that way? Neuroscience still can't fully separate nature from use. What we do know from the channel's own two networks framework is that the brain regions tied to abstract, spatial reasoning and the regions tied to social, verbal processing are in constant competition for resources. But three more discoveries quieter, stranger, went even further. And one scientist says all of it might mean nothing at all. Dr. Dalia Zaidel at UCLA examined slices containing Einstein's hippocampus, the structure that turns experience into memory. The neurons on the left side were noticeably larger than the right. In ordinary brains, that asymmetry barely exists. Her theory, a stronger link between the hippocampus and the neocortex, the seat of logic and analysis, meaning memory and reasoning in Einstein's brain, may have been wired closer together than in most people. Then came the corpus callosum, the fiber bridge, connecting the brain's left and right sides. Researchers compared Einstein's at age 26 against dozens of brains the same age. His was thicker, denser, built for faster communication between hemispheres, logic talking to intuition, and back again, without delay. Then, photographs Harvey had hidden for decades resurfaced. Dean Falk's team found something almost no one has. A fourth ridge in Einstein's mid-frontal lobe. Most people only have three. That region governs planning and working memory. His motor cortex also showed an unusual feature, one some researchers linked to his violin playing. Here's the analysis that undoes all of it. Every one of these studies compared one brain Einstein's against small control groups. Researchers knew which brain was his while measuring. That's not blind science. That's bias waiting to happen. Neurologist Terence Hines put it bluntly, every brain has unique quirks. Finding oddities in one man's brain and calling it genius isn't proof it's storytelling with a microscope. And Einstein wasn't even the first. Gauss's brain was measured for its convolutions. Lenin's was sliced into thousands of sections, searching for revolutionary genius. Even a 19th century criminal's brain was preserved just to see what made him different. None of it ever produced a formula for greatness. Science kept looking for genius in tissue. What it found instead was how badly we wanted genius to have a shape.